Hello and welcome back. This video is the second half of section 11.2. Last time we did a geometric series test to see if a series was convergent or divergent. We're now going to learn two more techniques. The first one being, actually we learned a couple things, but for this one, what we're going to do is we're going to use something called telescoping. A telescoping series. And what happens with a telescoping series is we are going to take this here, 1 over n times n plus 1, and we are going to use partial fraction decomposition on it. So I'm only going to do it for this one, just as a refresher, but for the other ones, I'm not. I'm just going to skip to the end. You can verify my work on its own. So we have this here, and what I'm going to do is I'm going to multiply through by the LCD, which is n times n plus 1. And then I'm going to get 1 equals a n plus 1 plus bn. And I'm going to rearrange this and rewrite the first part like this. And this is going to give me that a plus b equals 0 and a equals 1. And very nicely, if a equals 1, that means that b has to equal negative 1. And what all that means is that down here, we can rewrite this as one over n minus 1 over n plus 1. And what I'm going to do is I'm going to actually write that out. So this is going to give me, when n equals 1, I'm going to get 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus, and that goes on forever. However, I'm going to rewrite this as the limit as k approaches infinity, the summation of n equals 1 to k of 1 over n minus 1 over n plus 1. And that is going to give us this. That's going to be 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 and so on. However, this is going to give me to the 1 over k minus 1 minus 1 over k plus 1 over k minus 1 over k plus 1. So this is the k minus 1 term, and this is the k term. And what I'm hoping we can see is, like a telescope, the whole thing just collapses down on itself. And we can see negative 1/2 plus 1/2, negative 1/3 plus 1/3, and so on. In fact, everything will cancel on itself except for this term and this term. So this gives me 1 minus 1 over k plus 1. And if we were to do the limit on that and let k go off to infinity, as we know, when that denominator gets huge, the whole thing goes to 0. So what is the limit? 1. Now I want us to think about this. That means if I add up all infinity of those terms, it exactly adds up to 1. That should mess with your head a little. Also, we want to keep this in mind, that this summation here is equal to 1. We're going to use it a couple of times at the end. So we're going to try this again. And this one, I'm not going to do the full partial fraction decomposition. I will leave that to you. But this becomes summation is n equals 2. We have to start at 2 because if we start at 1, we're dividing by 0 to infinity of 2 over, and I'm going to factor that, n minus 1, n plus 1. And using partial fraction decomposition, this becomes this. 1 over n minus 1 minus 1 over n plus 1. So again, you'll have to do partial fraction decomposition, kind of like I just did a minute ago. And once again, I'm going to write this as a limit and I'm going to start writing these out. So this is going to be 1 limit as k approaches infinity of 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5 plus 1/4 minus 1/6 and so on until we get up to there's the k minus 1 term, minus 1 over k plus 1 over k minus 1 minus 1 over k plus 1. Now it's a little hard to see, but the only things that are going to survive are going to be this 1, and this 1/2, and then the negative 1 over k, and the negative 1 over k plus 1. Everything else is going to cancel out completely. And then minus 1 over k minus 1 over k plus 1. But once again, very nicely, these limits go to 0. So we end up with 3/2. Again, that should mess with your head a little. When I add up all infinity of those, it's going to exactly equal 3/2. Now, it's even more bizarre because if I only go up to the 100 trillionth space and add all those up, it's not quite 3/2. It's just under, just a little bit. We'll try one more. Once again, I will do the partial fraction decomposition separately. And this becomes summation n equals 1 to infinity of 1 over n minus 1 over n minus 3. So now they're a distance of 3 apart. Now you might notice here they were a distance of 1 apart, and we had 1 left over and 1 left over. For the previous one, they were 2 distances apart, right? 1 less, 1 more. So the denominators were 2 distances apart, and you'll notice there's 2 here and 2 here. So because these are 3 distances apart, I'm going to guess that there are going to be 3 that we preserve. And so let's start. Limit as k goes to infinity of 1 minus 1/4 1/2 minus 1/5 plus 1/3 minus 1/6 plus 1/4 minus 1/7. Now, made a small mistake. That's +3. And you can see they're a distance of 3 apart. Now, I'm hoping you can see here that the -1/4 finally is going to get canceled. So we're going to get a lot of things that are not. Let's talk about what we're going to keep. We're going to keep, so 1 over k minus 2 minus 1 over k plus 1 plus 1 over k minus 1 minus 1 over k plus 2 plus 1 over k minus 1 over k minus 3. And we are going to keep only that, that, and that, and then 3 here. So let's do this limit of 1 plus 1/2 plus 1/3 minus 1 over k plus 1 minus 1 over k plus 2 minus 1 over, I keep putting minus, k plus 3. And once again, let's all go to 0. When I add up 1 plus 1/2 plus 1/3, we get 11 over 6. All right. That brings us to, and by the way, I want to recall that this one exactly equals 1. I told you we were going to come back to that, and we are. All right. So because we have those rules where we can break them up, I can actually rewrite the first one, factor the 3 out, plus summation n equals 1 to infinity of, and I'm going to rewrite this slightly like that. Now, the very nice thing is that we know that this exactly equals 1. We just proved that a few minutes ago. Now, this becomes 3 times 1. Plus, now what happens here, notice the first term of this is 1/2. R is also 1/2. And because R is less than 1, then it's going to converge to A over 1 minus R. We learned that in the last video. 1/2 over 1 minus 1/2. Now, we need to keep in mind, let's say this part converged, this part didn't, then we say the whole thing diverges. It's like a true or false answer. If any part of it is false, the whole thing's false. All right, let's try this next one. So remember, E is the number 2.7 and change. So I'm going to go ahead and break this up. And this is looking like a geometric series to me. So I'm going to go ahead and rewrite it like this. All right. Now, these are both geometric series. And in this case, R is 2 over E. That is less than 1, because remember, E is 2.7. So we're good there. However, in this case, R is 4 over E. And that's going to look like this. 4 divided by E. That is definitely bigger than 1. In fact, I'll show you the other one. 2 divided by e. That's less than 1. So this first one, we're good. The second one, no. So this part diverges. Therefore, also diverges. So if either part diverges, we have to say the whole thing diverges. Now this next one's nearly identical to the example 13 that we just did. Remember, this part here, we've already proven equals 1. So this becomes 1 plus summation n equals 1 to infinity of 1 over e to the n power. Now, once again, this is geometric series, and 1 over e is definitely less than 1. A in this case is also 1 over e. Like this one's very similar to the first one that we did. So we're going to end up with 1 plus 1 over e over 1 minus 1 over e. And I'm going to try to clean that up a little. And I'm going to multiply the top and bottom both by e. So 1 plus 1 over e minus 1. And that's as good as we're going to get that, unless we want to get a common denominator, which we could do. It isn't necessary. And that is the end of section 11.2.